NEC Section 408.20 burn addresses the connection of ungrounded conductors within a panelboard. This section specifically prohibits the connection of ungrounded conductors belonging to different circuits within the panelboard. There is an exception for multi-wire branch circuits. Let's break down what this means in practical terms. A panelboard serves as a central distribution point for electrical circuits within a building. It receives power from the main service and distributes it to individual branch circuits, each feeding specific loads such as lighting, outlets, or equipment. Each branch circuit typically consists of a hot wire, a neutral wire, and a grounding wire. The hot wire carries the electrical current from the panelboard to the load. The neutral wire provides a return path for the current, and the grounding wire provides a safety path in case of a fault. The NEC, or National Electrical Code, is a set of standards for safe electrical installation. It aims to protect people and property from electrical hazards. Section 408.20 Bowen is a specific part of the NEC that deals with panelboard wiring. The key point of Section 408.20 Bowen is that you cannot connect hot wires from different circuits together inside a panelboard unless they are part of a multi-wire branch circuit. This means you cannot take a hot wire from one circuit and connect it to a hot wire from another circuit using a wire nut or any other type of connector. So, what is a multi-wire branch circuit? A multi-wire branch circuit is a circuit that has two or more ungrounded conductors with a voltage between them, and a neutral conductor that is common to both. These circuits are supplied from a single phase of a three-phase electrical system or from different phases. In a multi-wire branch circuit, the hot wires share a common neutral wire. This allows you to supply multiple loads using fewer wires. The NEC permits the connection of hot wires within a multi-wire branch circuit because they are designed to work together and share a common neutral. However, connecting hot wires from different, unrelated circuits can create dangerous situations. Firstly, it can overload the neutral conductor. If you connect two hot wires from different circuits to the same neutral wire, the neutral wire may not be able to handle the combined current. This can cause the neutral wire to overheat and potentially start a fire. Secondly, it can create unintentional parallel paths for current. Connecting hot wires from different circuits can create unintended paths for current to flow. This can cause equipment to malfunction or create electrical hazards. Thirdly, it can compromise circuit protection. Circuit breakers and fuses are designed to protect individual circuits from overloads and short circuits. Connecting hot wires from different circuits can bypass these protective devices and create a situation where a fault current is not properly interrupted. To summarize, NEC Section 408.20 Bowen prohibits connecting hot wires from different circuits within a panelboard, with the exception of multi-wire branch circuits. This rule is in place to prevent overloading the neutral conductor, creating unintentional parallel paths for current, and compromising circuit protection. It's crucial to adhere to this code requirement to ensure the safety and proper functioning of electrical systems. When working with panelboards, always identify the circuits clearly and avoid making any unauthorized connections between them. If you're unsure about any wiring practices, consult with a qualified electrician to ensure compliance with the NEC and other applicable codes. It is very important to know the correct rating of your electrical components. The ampacity of conductors must be appropriate for the amount of current that the conductor is rated to carry. Using conductors of the incorrect rating can cause them to overheat and melt. Also, electrical components that are not properly rated for the voltage they are exposed to can cause arcing and other safety problems. Always refer to the product's listing to confirm the correct usage of a product. An electrical panelboard is an assembly that has buses and automatic overcurrent protective devices. It may or may not include switches for the control of light, heat, or power circuits. It is designed to be placed in a cabinet or cutout box that is accessible only from the front. The NEC defines the requirements for electrical panelboards in Article 408. In the NEC, the definition of a circuit breaker is a device designed to open and close a circuit by non-automatic means. Also, it can open the circuit automatically on a predetermined overcurrent without damage to itself when properly applied within its rating. Switchboards are large panels that may be open in the rear and are generally accessible from the rear as well as the front. This is another difference between panel boards and switchboards. Overcurrent protection can be provided by fuses or circuit breakers. Fuses are one-time devices that must be replaced when they open a circuit. Circuit breakers can be reset after the trip open. The available short circuit current must be considered when selecting overcurrent protective devices. Devices must be rated to interrupt the available fault current. If the short circuit current rating of the overcurrent protective device is too low, it may explode during a fault. A multi-wire branch circuit is a type of circuit that consists of two or more ungrounded conductors that have a voltage between them and a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit and that is connected to the neutral or grounded conductor of the system. Multi-wire branch circuits must supply only to line to neutral loads. A three-phase multi-wire branch circuit has three ungrounded conductors, each 120 degrees out of phase with each other. A neutral conductor is also needed to provide a return path for unbalanced loads. A three-phase multi-wire branch circuit is very efficient because it has a higher capacity than a similar two-wire circuit. It is important to know the rules about working with electricity to keep yourself and others safe. The electrical work should only be performed by persons who are trained and qualified to do so. Electricity can be dangerous or even deadly when safety precautions are not followed. First, to energize the circuit and tag out the breaker. It is important to verify the circuit is de-energized with a meter. Then, use properly insulated tools when working on electrical circuits. Never work on energized circuits unless it is absolutely necessary. Wear appropriate personal protective equipment such as safety glasses and gloves. Be aware of the potential hazards of working with electricity and take steps to mitigate them. Follow all applicable electrical codes and regulations. Only make connections inside of an approved enclosure. Never leave wire connections exposed to the elements. Always use appropriately rated wiring and electrical components. If you are unsure about any aspect of electrical work, consult a qualified electrician. NEC Article 408 covers switchboards, switchgear, and panelboards. Switchboards have already been mentioned. Switchgear is a general term that describes assemblies of switchgear, circuit breakers, fuses, buses, and interconnections. Switchgear is typically used in large commercial and industrial installations. Panelboards are designed to be placed in a cabinet. The cabinet can either be flush-mounted or surface-mounted. Article 408.3 covers the working clearances around electrical equipment. Sufficient access and working space must be provided around all electrical equipment to permit safe operation and maintenance. The working space must be clear and unobstructed. The depth of the working space depends on the voltage of the equipment and the condition of the installation. Article 408.5 covers the number of overcurrent protective devices in a panel board. Panel boards are limited to a maximum of 42 overcurrent protective devices. A 2-pole or 3-pole circuit breaker counts as 2 or 3 overcurrent protective devices respectively. The NEC provides requirements on the use of surge protection devices in panel boards. Surge protection devices, also known as SPD, are devices designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, and other events. SPD are installed in parallel with the electrical equipment they are protecting. When a voltage surge occurs, the SPD diverts the excess current to ground, preventing it from damaging the equipment. NEC Section 230.67 requires surge protection for dwelling units. SPD must be installed at the service equipment or on the load side. NEC Section 708.20 requires surge protection for critical operations power systems. Critical operations power systems are systems that supply power to facilities that are essential for public safety, such as hospitals, fire stations, and police stations. SPD must be installed at the service equipment and at all distribution panelboards. The selection of an appropriate SPD depends on several factors, including the voltage of the electrical system, the available fault current, and the level of protection required. SPD are available with different voltage ratings, current ratings, and protection levels. It is important to select an SPD that is properly rated for the application. SPD must be installed in accordance with the manufacturer's instructions and all applicable electrical codes. SPD are typically installed in a panel board or in a separate enclosure. The SPD must be properly grounded to ensure that it can effectively divert surge current to ground. Regular maintenance is essential to ensure that SPD are functioning properly. SPD should be inspected periodically for damage or wear. If an SPD has been damaged or has reached the end of its service life, it should be replaced immediately. SPD are an important part of a comprehensive electrical safety plan. By protecting electrical equipment from voltage surges, SPD can help to prevent equipment damage, downtime, and electrical fires. Always make sure to work within the scope of your abilities and seek help when it is needed. Working on electrical projects without the proper experience can be very dangerous. Always follow the relevant electrical codes to ensure that your work is safe and compliant. The NEC is a very important document to follow when working with electricity. Always make sure that you are following the most up-to-date version. There may be local amendments to the NEC that you also need to follow. Electrical work can be dangerous and should only be performed by persons that are trained and qualified to do so. If you are not qualified, then seek help from someone who is. There is no shame in asking for help when working with electricity. It is always better to be safe than sorry. Making sure that all electrical equipment is properly grounded is important for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. All electrical equipment should be grounded in accordance with the NEC and other applicable codes. Grounding electrodes can be rods, pipes, or plates that are buried in the earth. The grounding electrode must be made of a conductive material and must be of sufficient size to carry the fault current. The grounding electrode conductor connects the grounding electrode to the electrical system. The grounding electrode conductor must be made of copper or aluminum and must be of sufficient size to carry the fault current. The equipment grounding conductor connects the metal parts of electrical equipment to the grounding system. The equipment grounding conductor must be made of copper or aluminum and must be of sufficient size to carry the fault current. Bonding is the process of connecting together all of the metal parts of an electrical system to create a continuous electrical path. Bonding helps to ensure that all of the metal parts of the electrical system are at the same voltage potential, which reduces the risk of electric shock. Bonding jumpers are used to connect together different sections of metal raceway. Bonding bushings are used to connect metal conduit to metal enclosures. Bonding lock nuts are used to connect metal boxes to metal conduit. Ground fault circuit interrupters, GFCIs, are devices that are designed to protect people from electric shock. GFCIs monitor the current flowing in a circuit and will trip the circuit if they detect a ground fault. A ground fault occurs when current flows through an unintended path to ground. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters of size are devices that are designed to protect people from electrical fires. SIs monitor the current flowing in a circuit and will trip the circuit if they detect an arc fault. An arc fault is a dangerous electrical condition that can cause a fire. SIs are required in many locations such as bedrooms and living rooms. Tamper-resistant receptacles are receptacles that are designed to prevent children from inserting objects into the slots. Tamper-resistant receptacles have a spring-loaded shutter that covers the slots. The shutter will only open when a two-pronged plug is inserted into the receptacle. Tamper-resistant receptacles are required in many locations, such as homes and childcare facilities. The NEC provides guidance on how to select the proper wire size for electrical circuits. The proper wire size depends on the amount of current that the circuit will carry and the length of the circuit. If the wire is too small, it will overheat and could cause a fire. The NEC provides tables that list the ampacity of different wire sizes. The ampacity of a wire is the amount of current that the wire can safely carry. When selecting a wire size, it is important to consider the ambient temperature. The ampacity of a wire decreases as the ambient temperature increases. The NEC provides correction factors that can be used to adjust the ampacity of a wire for different ambient temperatures. The voltage drop in a circuit is the decrease in voltage from the source to the load. Excessive voltage drop can cause equipment to malfunction. The NEC recommends that the voltage drop in a branch circuit should not exceed 3% and the voltage drop in a feeder should not exceed 5%. The length of the circuit, the wire size, and the current flowing in the circuit all affect the voltage drop. The NEC provides formulas that can be used to calculate the voltage drop in a circuit. Conduit is a protective enclosure for electrical wires. Conduit can be made of metal or plastic. Metal conduit provides better protection for the wires than plastic conduit. The NEC provides requirements for the type of conduit that must be used in different locations. Electrical boxes are used to enclose electrical connections. Electrical boxes can be made of metal or plastic. Metal boxes provide better protection for the connections than plastic boxes. The NEC provides requirements for the type of electrical box that must be used in different locations. It is important to properly support electrical boxes and conduit. Electrical boxes and conduit should be supported in accordance with the NEC and other applicable codes. If electrical boxes and conduit are not properly supported, they could fall down and cause a hazard. Always follow best practices when performing electrical work. Before starting any electrical work, it is important to carefully plan the project. This includes identifying the scope of the work, determining the materials that will be needed, and developing a detailed plan of action. Proper planning can help to ensure that the project is completed safely and efficiently. It is always a good idea to double-check your work. After completing any electrical work, it is important to double-check to make sure that everything is properly connected and that there are no loose wires. Double-checking your work can help to prevent electrical hazards. Consider using appropriately sized junction boxes when splicing wires. A junction box should be large enough to accommodate the number of wires that will be spliced in the box. The junction box should also be made of a material that is suitable for the environment in which it will be installed. Proper workmanship is essential for safe and reliable electrical installations. Electrical work should be performed in a neat and workmanlike manner. This includes making sure that all connections are tight, that all wires are properly routed, and that all equipment is properly installed. When working on electrical projects, it is important to maintain a clean and organized work area. A clean and organized work area can help to prevent accidents and can make it easier to find the tools and materials that you need. Always make sure to clean up your work area when you are finished working for the day. By following these best practices, you can help to ensure that your electrical work is safe, reliable, and compliant with all applicable codes. Remember that electrical codes can change. Regularly update your knowledge to keep up with revisions to the electrical code. Staying current can prevent errors in your work.